Hi, welcome to Praveen Daily. I'm going to post one video on embedded hardware design every day. So let's get started. In today's video, let's understand some electrical properties of the PCB material which affect the PCB performance. Dielectric constant or a relative permittivity, epsilon r or dk, it is the ratio of electric permittivity of the material to the electric permittivity of free space. It is also known as relative permittivity. The dielectric constant or relative permittivity, epsilon r, for most PCB materials is in the range between 2.5 to 4.5. Permittivity describes how a material responds to an electric field, how charge is distributed and how well electrons move within the material. A material with high permittivity polarizes more in response to an applied electric field than a material with a low permittivity, thereby storing more energy in the material. The dielectric constant varies with frequency and generally decreases as frequency increases. Some materials have less of a change in relative permittivity than others. We must choose a material which is suitable for high frequency applications or those whose dielectric constant remains relatively the same over a wide frequency range. For example, from few hundred megahertz to several gigahertz. Another electrical property of the PCB material which affect the PCB performance is the dielectric loss tangent or dissipation factor, tan sigma or dF. In transmission line design and RF design, dielectric loss tangent is defined with tan sigma, which is a measure of the rate at which energy carried by the electromagnetic field traveling through a dielectric is absorbed by that dielectric. The loss tangent is the phase angle between the resistive and reactive currents in the dielectric. The dielectric loss tangent of any material has a simple equation in terms of dielectric constant of that material, given by tan sigma equal to epsilon I divided by epsilon r. Epsilon I is the imaginary part and epsilon r is the relative permittivity of the dielectric material. If you know the imaginary and real parts of the dielectric constant, you can calculate the loss tangent. If you look at the PCB laminate data sheets, you will generally see a dielectric loss tangent value and a dk value. Just multiply these together and you get the imaginary part and dielectric constant. The dielectric loss increases with increasing values of dissipation factor. Lower values of dissipation factor result in fast substrate, while large values result in slow substrate. Dissipation factor dF gives a measure of the power loss in a dielectric material. Dissipation factor is a frequency dependent. Higher the frequency, higher the dissipation factor. Loss gets larger with frequency because the changing electromagnetic field causes the molecules in the dielectric material to vibrate more. The faster they vibrate, the more the loss. The value of dissipation factor for a PCB material ranges from 0.001 to 0.030. So that's all we have for today's video. If you don't want to miss video tomorrow, click on the subscribe button and let's see meet tomorrow.